Hello, again. I'm here with my AWS Security Service uh, program, and under this video and this episode, I want to talk about something that I know most of our workload doesn't require it, but for me, it's something that is very important. That whoever is managing workload around that should have opportunity to take a look, and that is what we call AWS IoT Device Defender. Security management across your IoT devices and fleets. If you look at AWS service very well, there is a tool called AWS IoT. So this tool allows you to connect your fleet in the across the feed to your AWS environment in such a way that you'll be able to stream telemetry. Now, there are security risks that is associated with this. And this IoT Device Defender is a fully managed security service that secure fleet of connected Internet of Things devices like smart medical devices, connected vehicles, or industrial manufacturing sensors. So that is what it does. That is what we talk about when we say IoT, Internet of Things. So why services like Amazon Inspector focus on standard cloud compute? The last time I talked about how inspectors scan, our EC2 instance and EKS environment. Now, in the case of IoT devices, inspector's capability doesn't extend to IoT devices. Now, what does, the IoT device defender does that. Devices operate out in the physical world, often have constrained processing power, use specialized protocol like MQTT, and can be physically stolen or tampered with. Device Defender continuously audits your IoT configurations, monitor device behaviors to ensure your fleet doesn't get compromised or turn into a botnet. Now, let me explain this. What that means is that Device Defender, IoT Device Defender, continuously monitor your fleet because there is a communication established between your fleet and the IoT hub. So it continuously monitor that is there any changes like behavioral changes, or maybe for instance, if there is for every 5 minutes if there is a pool that that connection is kind of you making. By the time they make it at the time and it's not there, that shows that there must be tendency that maybe it has been stolen or maybe it's damaged. So the work of IoT Defender is to do this work. Number one is audit continuously, check cloud device config against current security baseline. Now, if we have like 5 fleets out there, the job of this tool is to continually check the configuration to say, okay, does it comply with standard or, standard, security standard? The other thing is to dictate monitor and dictate the behavior. If there is any changes in behavior. For instance, like I said, is this still available there? Does this still send signal? And all those kind of things. So these are the two things. One, check if it's still behaving the way it should based on baseline. Three is that if it's there, does the configuration still align with standard that is expected? So these are the two things that IoT Device Defender does. Now, what are the core capability? Continuous control plane. Continuously evaluate your IoT core fleet configuration. That is what I said. It continuously allows you to evaluate your core fleet, configuration to say, okay, are they still in line with standard and compliance? Rule-based ML-powered behavior monitoring. That is number two, core capabilities. So monitor device-side metrics and cloud-side telemetry via two distinct mechanisms: rule-based detection and static threshold you define. Now, what this means is that you can say, okay, you can define some rules as to the behavior, and you can even define some threshold. For instance, you can say, okay, if the data that is coming from this particular device is lower than this threshold, then something is wrong. So you can do all those things. So rule-based and ML-powered behavioral monitoring can allow you to have an idea of what is going on out there. Dual telemetry stream analysis, cloud side versus device side. So collect, analyze multi-dimensional telemetry. It tracks cloud side metrics, e.g. number of authorization, failures, message size, connect, disconnect frequency, and stuff like that. And inject device side metric, e.g. listening network, port, running processes, local CPU memory. So it allows you to say, okay, what are the telemetry that is being captured? Then what are the information about the device that we have? So it allows you to have this kind of two stream of telemetry and analyze them. High operational, centralized mitigation actions and lifecycle alert. Integrate directly with AWS IoT core control plane to execute automated or manual mitigation actions. Like I said, it's just like an event bridge. There is a process that allows you to say, okay, if this happens, then we can do some real-time event-driven, responses. Okay, take this action, So business problem that this solve. Number one is massive fleet security drift. Compromise blind spot. If there is a security drift, if there is a compromise blind spot, you might not know. But with the introduction of IoT Device Defender, you can know that, okay, this particular device has not been sending, payload since yesterday. Maybe it's stolen, maybe it's spoiled. That could give you an option that's, okay, somebody should go there to go and check it. So there is no blind spot, and you notice or you notice a drift immediately. Severe scaling friction for multi-tenant token governance. Solve the operational risk of identity credential sprawling. Device Defender automatically audit your X509 certificate configuration and device profile across your whole registry. That shows that there's an inventory of your device and the certificate they are using. High operational overhead of tailoring behavior baseline. Bypass the complexity of setting manual threshold for diverse fleet by leveraging ML detect. So you don't do manual, but you can use machine learning detect to just, okay, this is the threshold we want to set for this, and if anything go beyond it, this is the action we want to want in return. So these are the business problem that is solved. Massive fleet security drift and compromised blind spot. Number two is severe scaling friction for multi-tenant token government, and high operational, number three, high operational overhead of tailoring individual baseline. Now, you can use just one baseline to, to say, okay, based on ML detect capability, and you have that done. So that is that. But for production best practices, embed security agent inside micro agent workload. For Linux or free RTOS edge platform, natively embed an open source IoT Device Defender security agent. So that shows that you have to have that agent installed on your devices so that it can communicate with the cloud, with IoT cloud. Enforce automated fleet quarantine via dynamic things group. Now, what you do here is that you build an automated response loop by mapping device defender alarm notification to event bridge. What does that mean? It means that if there is, you can automate your response pipeline. If something like this, if this happens to a particular fleet like this is what I want in response. Shut it down, upgrade this and that. So you can do that with event bridge. So these are the business problem. Enforce automated fleet quarantine. Implement strict certificate authority architecture. You can do that because now you have it properly architected for. Optimize metric collection frequency to balance cost and latency. So manage operational expenses, by setting a calculated metric report frequency. For high velocity, steady state IoT factory floor, configure your edge agent to batch and transmit device-side payload every 15 to 60 minutes rather than stream near real time. So now you have the opportunity to decide, how often you want to capture telemetry. That is what we call, that is the optimized metric collection. So you can say, okay, every 1 hour I want to capture this telemetry, instead of being locked down to read time all the time. But based on your business requirement and what you need, but the capability is there, you can solve that with this particular tooling to say, okay, this is the amount of data, telemetry I want to capture, this is where I want to capture it, and this is the velocity and the volume I want to capture. So these are the things you consider as a production best practices. Optimize metric, implement strict certificate authority, enforce automated fleet quarantine, and embed security agent inside your micro agent workload. Yeah, so that is all about AWS IoT Device Defender. And for other, hands-on practice, I will link another video at the bottom of this video. Once again, thank you.